everyone, welcome to this video. In this video we'll be solving this question which is asking us that about the centralizer of an element of a group. So they are asking, is it necessary that centralizer of some element of some group should be abelian? Is it necessarily true? So for that, let's take the group to be G, right? And within this group, let's take an element, let's call it to be small g. Now what would be the centralizer of this particular element? So according to the definition, it would consist of all the members x from the group G such that it commute with this small g. Those elements commute with G, correct? Now we need to check whether this set, which is centralizer of G, this is abelian or not. So if it is abelian, we have to provide a proof for it. If it is not abelian, right, in that case we need to give a counter example for it. So here the answer is that the centralizer is non-abelian in nature. Why it is so? Can you pause the video and think for the answer, think for a counter example and then come back? Okay, so here is my answer. The counter example that I am taking here is the dihedral group D4. Right, we already have studied about this group. This is the group of symmetries of a square consisting of 8 elements, which are rotations as well as reflections, R0, R90, R180, R270, H, V, D and D dash. Now according to the definition of centralizer, it will contain all those elements from D4 such that those elements commute with this particular element, which is R180. So here you see we have all the elements here, hence we have the complete group as the centralizer. Why that is so? Because you can check for each element. Obviously R0 being the identity would commute with R180. What about R90? R90 with R180 is 270. R180 with R90 is 270, right? The same. Hence they also commute. What about R180 with 180? So it would be R0, it is also commuting with each other. R180 with 270, you see it is R90, and R270 with R180 is again R90. So again the same. Again R180 with H, it is V, and V with R180, it is again what? It is, I'm sorry, we are checking R180 with H, it is V. H with R180 is V, right? So both are the same, hence it is commuting with each other. What about R180 with V? R180 with V is H. V with R180 is what? It is also H. So both of them, they are the same. What about R180 with D? R180 with D is D dash, and D with R180 is again D dash. So the same, right? And the last one is R180 with D dash is D, and D dash with R180 is again D. So you see all the elements here are commuting with R180, hence it is equal to our group. And we know the nature of this group. This group is non-abelian in nature. Why? Because you can find various pair of elements such that they do not commute. I am giving you here an example of H with R90. They do not commute with each other because the results, they are different. Hence this is non-abelian. If this is non-abelian, then that means the centralizer is definitely non-abelian because they both are the same, correct? So we have proved our result. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.